Hey everyone, ready for a deep dive into something really cool.
Always.
Today we're going to be looking at concept attention,
Ooh.
which helps us understand how AI models see images. We're going to be focusing on this research paper called Concept Attention Diffusion Transformers, Learn Highly Interpretable Features.
Cool.
So get this, AI models, especially those trained to generate images, can actually be used to locate specific objects within those images.
Oh, wow.
They can point out a dragon or a hole in a picture,
That's pretty impressive.
just like we do.
Yeah.
We'll be focusing on diffusion models,
Okay.
which are a powerful type of AI
Right.
that generate images from noise using text descriptions, almost like sculpting with words.
I like that analogy.
Our deep dive today will uncover how concept attention uses the inner workings of these diffusion models
Right.
to create saliency maps, which highlight the specific parts of an image that correspond to certain words.
So basically, it shows us what the AI is focusing on.
Exactly.
You know, one of the biggest challenges with AI,
Yeah.
especially those complex models, they often operate like black boxes.
Right.
We know what goes in and what comes out,
Yeah.
but understanding that the decision-making process in between can be tricky.
Yeah, it's like, how did it get there?
Right, and this lack of transparency can be a real problem, especially when AI is used in critical applications where trust is paramount.
Okay, so that's where concept attention comes in, right?
Exactly. Concept attention tackles this by feeding the AI model a list of concepts like cat, sky, tree, and then observing which parts of an image the model focuses on.
Makes sense.
What's fascinating is that the researchers found that analyzing the output of the AI's attention mechanism
Oh, wow.
produced much more accurate saliency maps than previous methods. It's like we can finally see what the AI is thinking
Right.
and how it connects words to visual elements in the image.
Okay, I'm following so far, but could you break down this
Sure.
attention mechanism a little bit more? For those of us who aren't AI experts, what does that even mean?
Sure, think of it this way. When we humans look at an image, our attention naturally gravitates towards certain elements, maybe a bright color or an unusual shape.
Right.
AI models have a similar mechanism where they learn to zero in on specific parts of an image relevant to the task at hand.
Okay.
In this case, it's connecting a word like dragon to its visual counterpart in the picture.
So it's like the AI model is learning to focus on what's important, just like we do.
You got it.
And this output space you mentioned earlier, is that where we see the results of this focusing process?
You got it. The output space refers to the information the AI model produces after it processes the image and the given concepts.
Okay.
It's in this output where we find valuable clues about how the model is thinking
Yeah,
and what it's paying attention to.
that makes sense.
Mm-hmm.
So by analyzing this output, concept attention can create these highly accurate saliency maps,
Right.
basically highlighting the specific parts of an image that correspond to those given words.
E-
But how did the researchers actually test whether these maps were truly accurate?
Good question.
Did they put concept attention through some rigorous challenges?
They absolutely did. They tested concept attention on a task called zero-shot image segmentation.
Okay.
This means the AI has to identify and outline objects in an image without any prior training on those specific objects. It's like showing the model a picture of a rare bird
Oh, wow.
it's never seen before and asking it to perfectly trace its outline against the background.
Wow, that sounds incredibly difficult.
It is.
I wouldn't even know where to begin if someone asked me to do that.
Right.
So how did concept attention perform? Was it able to rise to the challenge?
The results were seriously impressive.
Okay.
Concept attention not only performed well, it actually outperforms several other existing methods. It even achieved state-of-the-art performance on benchmark datasets like ImageNet segmentation and Pascal-Vix, which are like the gold standard for testing these types of AI tasks. It successfully located and outlined objects, even those it had never encountered before.
Okay, now I'm really curious to see this in action. Are there any specific examples from the research that we can walk through to really get a sense of what this looks like?
Absolutely. The research paper includes some truly striking examples in figures 1, 3, and 5.
Let's start with figure 1. It shows a few different images,
Okay.
each with saliency maps generated by concept attention and some other methods. There's a picture of a parrot in the snow.
Yeah, and notice how accurately concept attention isolates the parrot, even against that white, snowy backdrop.
Yeah.
The other methods just can't seem to get it quite right.
Wow, it's so precise you can clearly see the outline of the parrot, its beak, even its tiny feet. And in figure 3 with the image of the man holding flowers, it's like the AI is understanding exactly what we're asking and showing us what it sees.
Right, and in this image, concept attention accurately highlights the man, his face, the flowers in his hand,
Yeah.
and even distinguishes the sky from the background grass and trees.
Okay, I have to admit, this is pretty mind-blowing.
Yeah.
But I'm guessing there are limitations to this technology, right? It can't be perfect,
Of course, you're right. This field is still relatively young.
right?
And even concept attention has areas for improvement. For instance, it currently works best with single word concepts,
Yeah.
like identifying a cat or a dog.
Okay.
It might struggle with more complex phrases or sentences.
So while it's a remarkable step forward, there's
Yes.
still a lot more to explore and refine. What does this all mean for us, though? Why should our listeners care about concept attention?
That's a great question.
And this whole idea of understanding how AI sees.
That's a crucial question. If we connect this to the bigger picture, understanding how AI models see is crucial for several reasons. Firstly, it helps us build trust in these systems,
Okay.
which is essential for wider adoption and application, particularly in sensitive areas. If we understand how they make decisions,
Right.
we're more likely to trust them with important tasks.
Makes sense.
Secondly, understanding their vision allows us to control their behavior more effectively.
Right.
We can fine-tune them to perform tasks more accurately and avoid unintended consequences. And lastly, it opens up exciting possibilities for collaboration between humans and AI. Imagine working with AI systems that comprehend our instructions,
Oh, wow.
learn from our feedback, and even help us see the world in new and unexpected ways.
Okay, I'm starting to see how this could be a game changer. But before we get ahead of ourselves,
Okay.
let's go back to something you mentioned earlier. The idea that diffusion models perform best when there's a bit of noise in the input images.
Oh, yeah.
That seems counterintuitive. Why would adding noise make the model more accurate?
It's a fascinating concept, isn't it? It has to do with the way these models learn. Diffusion models begin with pure noise
Hmm.
and gradually refine it into a coherent image based on the text description.
Okay.
During this process, the model actually learns to pick out and amplify the most crucial features
Right?
while suppressing irrelevant noise. It's like the noise acts as a filter,
Yeah.
forcing the model to focus on the essence of the image.
So in a way, the noise is helping the model refine its understanding and focus on what's truly important. It's like a training exercise for its vision, right?
Exactly. It's a good reminder that sometimes a little bit of randomness can actually lead to better results.
This deep dive has been packed with information, and it's really impressive to see the progress being made in AI interpretability.
It truly is a rapidly evolving field, and I'm excited to see researchers constantly pushing the boundaries of what's possible.
Before we wrap up this part of our deep dive,
Okay.
I want to circle back to another point from the research. The impact of layer depth on segmentation performance.
Mm-hmm.
Now, I know we haven't delved too deep into the technical details of these AI models,
Sure.
but could you give us a quick explanation of what layers mean in this context?
Of course. Think of each AI model as being built with multiple layers,
Okay.
and each layer performs a different operation on the data it receives.
Mm-hmm.
It's like a complex assembly line where each station adds something new to the product.
Right.
In the case of diffusion models, the deeper layers handle more abstract and complex representations of the input image.
Okay.
They've processed more information and have a more in-depth understanding of the content.
So the researchers found that these deeper layers are particularly important for segmentation performance.
Yes, they observed that using information from the deeper layers of the AI model significantly improved the accuracy of the segmentation results. It's as if the model's understanding of the image becomes more refined and precise
Right.
as it processes the information through these deeper layers.
That makes sense. It's like we're getting a clearer picture of the AI's thought process as we delve deeper into its internal workings. We've covered a lot of ground already, but there's still more to uncover. Stay tuned for part 2, where we'll discuss further implications of concept attention and its potential impact on AI development.
Welcome back to our deep dive into concept attention.
It's amazing to think that we can now get a glimpse into how AI models actually see images, thanks to this research.
Right.
Before we went to part 2,
Yeah.
we were talking about how concept attention reveals how AI models connect words to images, and it's making me think about the bigger picture.
Mhm.
What kind of impact could this have on the development of AI,
Well,
especially when it comes to things like ethics and responsibility?
that's a crucial question. As AI keeps evolving and becoming more powerful,
Right.
we need to carefully consider both the positive and negative impacts it could have on society.
Yeah.
It's not just about the technology itself, but
Right.
how we use it.
Let's start with the positive. How could concept attention be used to make AI development more ethical and responsible?
One really promising area is in building more transparent and accountable AI systems.
Okay.
Imagine being able to use concept attention to audit an AI system used for loan applications, for example. We could check if it's making fair decisions
Right.
or if there's any bias against certain groups of people.
Yeah.
Concept attention gives us a tool to actually see inside these systems
Right.
and identify potential issues that might otherwise go unnoticed.
That makes a lot of sense. Transparency is so important,
Yeah.
especially when AI is making decisions that affect people's lives. What are some other potential benefits we might see?
Another exciting possibility is using concept attention to improve how we control AI.
Okay.
If we understand how these models process language and connect it to visual information,
Right.
we can interact with them in more intuitive ways and guide their behavior.
Right.
It could lead to amazing new forms of collaboration between humans and AI, where AI becomes a powerful tool for creativity, problem solving,
Yeah.
and scientific discovery.
It's like we're moving from a world where AI is a mysterious black box to a world where we can work alongside it, understanding its strengths and limitations.
Exactly. It's about partnership, not replacement.
But of course, with any powerful technology, there's always the risk of misuse.
Right.
Could concept attention be used for unethical purposes?
It's important to acknowledge that any technology, especially something as powerful as AI,
Yeah.
can be misused.
Right.
One concern is the potential for manipulation and deception.
Okay.
If someone understands how AI models see, they might exploit that knowledge to create harmful or misleading content.
Right.
Imagine someone using concept attention to create incredibly realistic deepfakes,
Oh, wow.
making it even harder to distinguish truth from falsehood.
That's a disturbing thought.
Yes.
It really emphasizes the need for careful consideration of the ethical implications of AI.
Absolutely. As research progresses and we develop tools like concept attention,
Right.
we need to have open and honest discussions about responsible use and put safeguards in place to prevent harm.
Yeah.
We need to make sure AI development benefits society as a whole.
It's like we're entering a new era where we need to strike a balance between the immense potential of AI and the responsibility to ensure it's used ethically.
I completely agree. Research like this that focuses on understanding and interpreting AI
Right.
is a vital step in that direction. By learning how AI models see, we're in a better position to harness their power safely and responsibly.
Before we move on to the last part of our deep dive,
Okay.
I want to revisit something we talked about earlier. The idea that adding noise to input images actually improves the performance of diffusion models.
Oh, yeah.
Why does this work? It still seems a bit counterintuitive.
It's a fascinating phenomenon. It relates to how these models learn.
Okay.
Remember, diffusion models begin with pure noise
Right.
and progressively refine it into a coherent image guided by the text prompt.
Okay.
Throughout this process, the model is learning to identify and enhance the most important features in the image while suppressing irrelevant noise.
Right.
The noise almost acts like a training mechanism,
Yeah.
forcing the model to distinguish between signal and noise and focus on what's essential.
It's like the noise is helping the model develop a more refined eye for detail.
Yes, it's another reminder that sometimes a bit of randomness can lead to surprising and beneficial results.
We've covered so much ground in this deep dive already. We've talked about the capabilities of concept attention, its potential impact on AI development, and even touched on the ethical considerations. What's next on our agenda?
In part 3, we'll get into the specific tasks and applications where concept attention could be most impactful.
Okay.
We'll also look at the limitations of the current approach and explore potential avenues for future research.
Sounds like we have a lot more to explore. We'll be right back to wrap up this fascinating journey into the world of AI interpretability. Welcome back to the final part of our deep dive into concept attention. I'm really curious to explore the practical applications of this technology. We've talked a lot about how it works and the potential impact.
Right.
But where could we actually see it being used in the real world?
That's what makes it so exciting, right? Trying it move beyond the research lab. One area that immediately comes to mind is medical imaging.
Medical imaging?
Yeah, think about it.
Okay.
Using concept attention to analyze medical images like
Yeah.
X-rays, MRIs, or CT scans,
Right.
doctors could use it as a tool to pinpoint subtle abnormalities
Wow.
that might be difficult for the human eye to catch. It could lead to earlier and more accurate diagnoses, which is, of course, critical for effective treatment.
That's a fantastic application. It sounds like it could really augment the expertise of medical professionals.
Exactly. That's the key. Using AI to enhance human capabilities, not replace them. Concept attention could provide valuable insights,
Right.
but ultimately it's still the doctor who makes the final diagnosis and treatment decisions.
What about other fields? Are there any other areas where concept attention could be particularly useful?
Absolutely. Self-driving cars are another area where concept attention could have a big impact. Imagine being able to use it to understand how the AI system in a self-driving car is perceiving its surroundings.
Oh, interesting. Okay.
Yeah, we could identify potential hazards, improve navigation,
Hmm.
and even use it to explain the car's decisions to the passengers,
Oh, wow.
which could build trust and make people feel more comfortable riding in autonomous vehicles.
It's like giving the car a voice,
Right.
so it can tell us why it's making certain decisions.
Exactly.
That could definitely help with the adoption of self-driving technology.
Yeah.
What about robotics? Could concept attention play a role there?
Definitely. In robotics, concept attention could be used to create robots that are more intuitive
Hmm.
and responsive to human instructions. It could allow robots to better understand their environment and interact with it in a more nuanced way,
Okay.
leading to advancements in areas like manufacturing, healthcare, and even personal assistance.
So many possibilities. It seems like we're just scratching the surface
Yeah,
of what concept attention could be capable of.
it's a really exciting time.
But we've also talked about some of its limitations,
Right.
like how it currently works best with single-word concepts.
Yeah.
How might future research address these limitations and make concept attention even more powerful?
I think one key area for future research is exploring how to expand concept attention to work with more complex concepts, phrases, or even entire sentences.
Oh, wow.
This would allow us to probe the AI model's understanding at a much deeper level. Instead of just
Right.
asking, where's the cat?
Yeah.
We could ask, is the cat sleeping? Or what is the cat looking at?
It would be amazing to have that kind of nuanced interaction with AI models.
It would.
Are there any other areas where future research could make a difference?
Another exciting direction is exploring how concept attention could be integrated into the training process of AI models.
Oh, okay.
Currently, it's mainly used as a tool for analyzing models that have already been trained, but what if we could use it during training to guide the learning process and improve accuracy? It would be like having a teacher who can point out the model's mistakes and
Right.
help it learn more effectively.
That's fascinating. It could lead to AI models that are more robust, reliable,
Exactly.
and aligned with human values right from the start. This entire deep dive has been incredibly insightful. We've gone from understanding the basics of diffusion models to exploring the capabilities of concept attention
Yeah, it's been great.
and its vast implications for the future of AI.
It's clear that research in AI interpretability is moving forward at an incredible pace.
It really is.
Tools like concept attention are giving us valuable insights into how these models work, which is essential for building trust and ensuring responsible development.
As we wrap up this episode, I want to leave our listeners with this thought. The future of AI is being shaped right now. As we continue to develop powerful tools like concept attention, it's up to all of us to engage in thoughtful discussions about their ethical implications and work together to guide AI development in a direction that benefits all of humanity. Thanks for joining us on this deep dive. Until next time, keep exploring, keep learning, and keep asking questions.